applications of quadratic equations. And while there are a lot, for this particular example, we're going to throw a ball off a building. So you decide to get crazy while on vacation. You know, throw a ball vertically upward from the top of your hotel 288 feet off the ground with an initial velocity of 48 feet per second. That distance, noted by D, in feet of the ball from the ground after t seconds is shown by the formula D equals negative 16 t squared plus 48t plus 288. Now that formula, the 288 is how many feet off the ground you started. That 48 that's in front of the t, that's your initial velocity. And the negative 16 represents the pull of gravity. So that's where the formula comes from. Now, after how many seconds will the ball hit the ground, and how long will it take the ball to pass the top of the hotel on its way down? So those are the two questions we're going to address. Question number 1. After how many seconds will the ball hit the ground? Well, we know if the ball hits the ground, that means the distance from the ground, which is D, will be 0 because it's on the ground. And therefore, we can substitute in 0 for D into our initial formula, and now we have a quadratic that we can solve. So first, let's make this nice and easy. Let's factor out a negative 16 from each term to make our quadratic just a little bit easier to play with. So that gives us 0 equals negative 16 times the quantity t squared minus 3t minus 18. Part of the reason why I factored out a negative 16 was so that my quadratic term, the t squared, be positive. So now when I'm looking at the t squared minus 3t minus 18, I notice I can solve that by factoring. That factors to t minus 6 and t plus 3. So I have completely factored my quadratic. Now to solve that, well, we know by the zero property rule, zero product rule, that I can set t minus 6 equal to 0 and t plus 3 equals 0. So the time it takes for the ball to hit the ground is either 6 or negative 3. Now, we're talking about time. We have negative time, right? We are not going backwards in time. Haven't figured that out yet. So we cannot use negative 3. So the ball will hit the ground after 6 seconds. Just t equals 6 is when the ball will hit. 2. How long will it take the ball to pass the top of the hotel on its way down? Well, from the initial question, we know that the top of the hotel is 288 feet off the ground, and therefore D, the distance from the ground, is 288. So if I substitute in the 288 for D into the equation, I could do that. And now to solve a quadratic, we need to set that equal to 0. So if we subtract 288 from both sides, we end up with 0 equals negative 16t squared plus 48t. Again, we're going to factor out a negative 16, and not just that, but a negative 16 because we only have two terms now, and then we have a greatest common factor. So we have negative 16t and t minus 3. When I solve those, I'm going to have two answers, right? If negative 16t equals 0, then t is just 0. And if t minus 3 is 0, well, then t is 3. So if you think about these two answers, when time is 0, that means we have not thrown the ball yet. We are standing on the top of the hotel, 288 feet up above the ground, and we are holding the ball. Then at t equals 3, right, 3 seconds after I've thrown it, that's when the ball is coming back down. So at t equals 0, I have the ball, I throw it vertically upward, and after 3 seconds, it passes the top of the hotel. As we know from the last answer, at 6 seconds, the ball has hit the ground. And there's a little bit of fun with quadratic equations.